Hello viewers, Wagadaru now taking you through today's story of on O-level math contest practice. So this video will be mainly a compilation of the basics of algebra part 1 for the training which took place in 2023. Basically for that training was basically for senior 1 and senior 2 students who hope to do math contests when they reach senior 3 and senior 4. So that means that by this year, 2026, they are now joining A level, meaning that we have to change the style of training from O level way to the A level way. But before we go to the A level training, I thought it is better to release these compilations of what we are trained for O level so that in case there's a student joining S5 but never did math contests in O level, can go through these videos and be on the same track like those who did it in O level. For those who are still in O level, this video is a must watch. There's no way you can run away from it. So I encourage you to make good use of this video so that we can progress from the O level way to the A level way of math contests. So before we begin, I would like to show you the books we recommend for the new curriculum syllabus. So for O level, there are 2 books of math notes for senior 1 and senior 2, and the item bank for senior 1 to senior 4. Physics, there's a physics book from senior 1 to senior 4, and also an item bank from senior 1 to senior 4. So in case you need copies, contact the author on this contact. That is for O level. Then for A level, these are the books so far. There is Math 1, Math 2, and the Math item bank. Then there is Physics 1, Physics 2, and the Physics 2 item bank. So this Math item bank is mainly for pure math, and the Physics item bank is mainly for Physics 2. That means that the Applied Math item bank and the Physics 1 item bank are still pending, but will be released with time. So with those few remarks, let me leave you with the recordings of the compilation of basics of algebra. Hello viewers, we are Daruna taking you through the story for O-level math contest practice. And this video, we're going to go through the part of expansion of algebraic expressions. So this video is under algebra and is suitable for students in senior 1 and senior 2 who hope to one day participate in the math contests and math Olympiads. So this is the plan or the strategy for this week. So shall use 6 days of the week, and the first day will be on this, which will involve something about expansion on algebraic expressions and MC. MC means math contest. So math contest assignment 1. Now this one is not connected to the assignment. This one is to help you to bridge the gap so that even senior 1s and senior 2s can level up to the standard of the national math contest. Because remember, in senior 1 and senior 2, there are some topics you have not yet covered, yet those in senior 3 and senior 4 have covered. So you are trying to bring out those topics which will help you in the math contest. Remember, math contest is what qualifies you for the math Olympiad. And math Olympiad has 4 main branches or 4 main areas of assessment. There's algebra, integers or number theory, geometry, and combinatorics. So we are going to that, and for that reason that you have chosen to pick out this part of algebra which is covered in class, so that even the senior 1s and senior 2s can know something about this algebra and be able to compete. So these math assignments will be got from the previous math contests which have been set all the way from 20 all the way from 2000 to 2023. So we have arranged these questions topic by topic in a way that a student can go through them. So there will be this week there will be 4 assignments: assignment 1, assignment 2, assignment 3, and assignment 4. And these other days will be for solutions to those assignments. So we expect you to get time and have the passion to go through these assignments. They can be somehow challenging, but you have to persevere, and that is the quality of a student who will participate in the national math contests and thereafter math Olympiads. So this video will involve something small, and that is called expansion of algebraic expressions. In your primary, you did some expansion, and that's what we are going to start with and build on. So the first expansion we shall look at is an expansion which has only one bracket. So I think I can see here, if you are given one bracket, what you should remember is that the term outside the bracket multiplies each term inside the bracket, and that's what we call the distributive law. As you can realize here, there was this term, it multiplied by this to give you a B, then it also multiplied by this to give you a C. Same applies to this term outside multiplied by B to give you a B, and also multiplied by C to give you a C. Note that the sign does not change, it remains the same. If it was minus, it remains minus. If it was plus, it remains plus. And that trick is what we shall use to go through these questions. All those parts. So let's start with part A. What they want you to do is to remove the brackets and simplify. Simplifying means if they are like terms, you have to collect them. So part A, we are given 3 in brackets x minus 2y. So what we do, we multiply 3 by x to give you 3x, then minus remains, then multiply 3 by 2y to give you 6y. There's no like term, so you can stop there. Part B, we are given that, so this term outside will multiply by this to give you 2x squared, again multiply by this to give you 4xy, again multiply by this to give you 2xz. I think we realize that the signs have remained the same. So basically that is the logic behind expansion. Now here we're given this term which is alone and this one which contains a bracket. So what we're going to do, we are going to first multiply this with this and also this with this, but remember there was this minus which will confuse the students. So what you're going to do, first maintain this bracket and just bring this 4 alone inside to give you 8x, then bring this one with this to give you 12. Then from there you will again open here, there is a side, you can now open brackets, because there is 1, like -1 times this, it gives you negative 8x. The negative times the negative gives you a positive. Now this is the trick I was telling you about. If you don't use brackets very well, you may think that this will remain a minus, but it changes because of this negative which is outside. It is okay To move from this step to this step, I only brought this to show you, to easily explain how this plus comes about. Part D, they gave you that. So yeah, what they want us is to collect like terms. You realize that there is this and this. So 3y plus 2y gives you 5y. Okay, then there is also this and this. So 2x minus x gives you positive x. This one is alone, you just put it there. And that's what they wanted. Then yes, still somehow connected to this. So I'm going to follow the same procedure. Bring this one inside to give you this 3x times 2x gives you 6x squared. Then 3x minus 3x times 3 gives you 9x. Then this maintains. Now here we have not done like this because it is the one with the negative outside the bracket which is more tricky, but this one was a plus. That is why we didn't bother about this bracket. Simplify this minus that gives you negative 2x. So with that, I will expect you to try out these questions. Now this is just exercise. Exercise means it is connected to what we have covered in the previous slide. But when it comes to assignment, it is basically chosen from the math contest which was done previously. And it is selected in such a way that you have some idea of, it is connected to the idea of what you covered in primary and what has been covered in the current video, meaning that you will be able to attempt those questions. They are 5 well-selected questions. So if you're in senior 3 and you already covered this part of algebraic expansion, for you can just forward and go to towards the end of the video, you'll find there the assignment and you try it out. So now we shall go to the next trick, which is called expanding two brackets. Previously, it was only one bracket, but the question is, what if there are two brackets? So still use the distributive law several times. How is that done? You are going to first say this alone will multiply the whole of this bracket and it gives you this. Then also this alone will multiply the whole of this bracket and gives you this. Now this plus comes from here. Then from there we shall now still use what I think we realize now. We have a bracket and only one term outside. So for the procedure, this times this to give you that. Then this times this to give you this. This times this to give you this. And this times this to give you that. That is if there is plus. What if there is minus? Still do the same. This one multiplies by the whole of this to give you this part. Then this multiplies by the whole of this to give you this part. Then this minus comes from here. Okay, then we start. This times this gives you AC. This times this gives you AD. Then you realize that here there is minus, so it is here. Then here, this times this gives you this. Now the minus comes from here. Then this times this gives you this. But realize there is a plus. Why is it so? It is because of this negative times a negative. So negative times the negative gives a positive. That is actually the most trick they put in such expansions. You should remember that negative times the negative gives a positive. And with that, let's go through these questions, these parts A, B, and C. So this is what we have in part A. First thing to do is to get this x times the whole of this, then this 5 times the whole of this. Then we bring the x inside. So x times x, x squared, x times 3, 3x, 5 times x, 5x, and 5 times 3, 15. All are plus because of this. Then we collect like terms. 3x plus 5x gives you 8x. That was part A. Then part B, still do the same. This times this, then minus this times this. Okay, then we expand using the distributive law. This times this gives you this 8xy, then plus this times this gives you 6x. Okay, then minus 3 times this to give you 12y, then negative and a positive gives a negative. Then 3 times 3 gives you 9. Then from there, look for what is, if there are like terms to collect, but in this case, there are no like terms. So we shall stop there. Part C, it was that. So what you're going to do, you're going to first maintain the 3 outside and put this in a box bracket alone. Can you expand this first? So bring this x times this to give you that. Bring this 1 times this to give you that. Then again, open brackets, this times this, it is x squared, this times this, minus 2x, 1 times that, it is x, 1 times that, it is minus 2. So remember, we still have the 3 outside, so it has to go inside. But before it goes inside, you realize that we have like terms here. So negative 2x plus x, that is the same as negative 2 minus 1, which is negative 1 times x to give you negative x. Then you can now bring the 3 inside. It multiplies each term. This times this times this, and this times that. So with that concept, you can now attempt this exercise. So you can pause the video, attempt it. Now we shall go to what we call perfect squares expansion. So the expansions in this form, a plus b squared, a minus b squared, are what we call perfect squares. And expanding it is what this part is all about. So how do we do it? We know that a number which is squared means multiplying it by itself 2 times. So a plus b squared is the same as a plus b times a plus b. I think we realize that now we have got what we have covered previously. So get this times the whole of this, then this times the whole of this, like that. Then we again bring it inside. This a times a is a squared, a times b is ab, b times a is ba, and b times b is b squared. Now these two are the same because in multiplying, this is the same as this. So that's why we are saying that this is the same as this, so that when you add the 2, you come up with 2ab. And that's the expansion. So we can thus state that the perfect square expansion rule. And the rule is that this squared is equal to x squared plus 2ab plus b squared. And we can remember it through these 3 steps. The first step is that square the first term. Okay, you see that? Let's repeat. They said square the first term, so come and get the first term, square it. Okay, then step 2, add twice the product of the first and last terms. Add twice. So the product of first and last is a times b, which is this. But they said twice. That is why you're adding this 2. And they said add. That's why it is this. Okay. Then step 3. add on the square of the last term. Square of the last term. So those are the three rules which can help you to expand. The most common mistake is students thinking that when it is this, it will just be a squared plus b squared. That is the most common mistake, but I encourage you not to do such a mistake. So you should remember that for one, square the first term, then add twice the product of the first and the last term, then add the square of the last term. Similarly, if it is minus, it means that here it will now still be the same, only that now here instead of being positive b, it is negative b. So that's why here you see minus, because a times negative b becomes negative. But negative b squared remains positive. That's why this is positive. So when there is a minus, it is twice the product of the first and last term which gets a minus. So with this knowledge, you can now go through these examples. So example 1 says expand x plus 3 squared. So we shall still follow the rule. 1, square the first term, then add twice the product of the first and last term, which is that. Then add on the square of the last term, which is that. So that is the 3 steps. Then next is simplify, because 2 times 3 is 6, then times x is 6x. Then 3 squared is 9. And you are done with the expansion, as simple as that. That was part A. Now we shall go to part B. Part B, they gave you that, so we are going to do the same. Square the first term, okay, minus twice the product of first and last term, then square the last term. When you simplify, you'll come up with that, and that's what they wanted. Then part C, it was like that, so still do the same. Square the first term. The first term is 5x. Add on twice the product of first and last term, then square the last term, and simplify. So 5, this power is on both 5 and the x. So 5 squared gives you 25, then x squared is this. Then here 2 times 5 times 1 gives you 10, but there is this x. 1 squared is 1, and that's what they wanted. Then this one, still the same. Square the first term, minus twice the product of first and last term, then square the last term. And then simplify. 4 squared is this. Then 2 times 4 times 3 is 24. The minus is there. Then this one means 3 squared to give you 9, and x squared to give you x squared. Then part E. So the same. Square the first term. Add on twice the product of the first and last term. Then square the last term. Now 2 squared is 4. Then x squared times x squared, then you square it, is the same as x squared times x squared. Remember, this is x squared. X squared is x times x. Then you again have x squared, which is x times x. So that's why you have 1, 2, 3, 4. That's why you have a power of 4. Then 2 times 2 times 3 gives you 12. There is this x squared. Then 3 squared is 9. And that's what they wanted. Then part F, it is that. So you're going to put a box bracket here and expand only this first. So first term squared, twice the product of first and last term squared. Simplify. 2 times 2 is 4. There is x, that's why there is x squared for x. Then here 2 squared is 4. Then now open brackets, this by this becomes that, this by that, sign changes, this by this, sign changes. Then you collect like terms, there is this 5 and this minus 4 to give you positive 1. And that's what they wanted. So with that, you can go through these exercises. Now we shall go to further expansion. Further expansion, previously there have been 2 brackets, but each has been having two terms. What if one bracket has 3 terms? So what you do, you put the one with 2 terms in front of the one with 3 terms. Then you'll say this multiplies by all this to give you that, and this multiplies by all this to give you that. Then from there you can use the distributive law, which says this times this, sorry, this times this is SC, this times this is AD, and this times this is AE. Then go to this times this, BC, this times this, BD, this times this, BE. Basically, that's what you follow, and shall use that to go through these questions. The first question is that, so shall do the same, this by the whole of this, and this by the whole of that. Then each term is multiplied. This with this is x cubed, this with this 2x squared, this with this 4x. Then this with this 3x cubed, 3x squared, this with this 6x, and this with this 12. Then we look for like terms to collect. If you look at this, it is also here. So 2x squared plus 3x squared gives you 5x squared. Okay. Then also when you look at this, it is also here. So 4x plus 6x gives you 10x. And that's what they wanted. Then part B is that, so we are going to first expand these 2. Then we shall go to the other. So expanding these 2 will give you still the rule, this with the whole of this, and this with the whole of this. Then expand it further, that box bracket, this with this, x squared, this with this, 2x, minus this to give you 3x, then this and this gives you minus, this with this gives you 6. Then you collect like terms of these 2 to give you -1, which is -x. Now I can expand this with that. X will go through the whole of this second bracket, and 1 will go through the whole of the second bracket, as you can see here. Then this with this, this with this, this with this, 1 with this, 1 with this, 1 with this. Then you collect like terms. You realize that this one and this can cancel out. Okay. The negative 6x minus x gives you -7. And you have simplified what they wanted. Part C was that, meaning that if there is a cube, it means it multiplies by itself 3 times. So which is the same as this times this times this, which is this times this squared. Then this one shall use the rule we saw in the of perfect square, that square the first term, add twice the product of first and last term, then square the last term. Then simplify to give you that. Now I can expand this with the whole of this, and this with the whole of this. Then each term now, this with this, 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 and this with this. Then you calculate like terms. We have this and this to give you 6x squared. Okay. Then you also have this with this to give you 12x. And there we have done what they wanted. So with that, we can go through this exercise. And these are some of the useful expansions which you may need to know. Especially these two here. Because even in the O-level syllabus, these two are there. But in math contest, we add on the ones for cubed. Now we shall go to the longer-awaited assignment. So this assignment will require you to reason a little more and come up with a solution. So the first one came from NMC 29. NMC means National Math Contest of 2019, paper 1, question 1. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solving linear equations. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family. Hello viewers, who are gonna take you through the story of O-level mathematics contest practice. And this video we're going to go through the part of solving linear equations. So this video is suitable for students in both Senior 1 and Senior 2 who have the passion of math and hope to one day participate in the national math contest and also mathematics Olympiads. So this is day 2, day 1 week. We have already covered the expansion and I left you with an assignment. Hope it is going smoothly with it. You are going smoothly with it. And now we are going to day 2, which involves solving linear equations. And also at the end of the video, I'll give you another assignment. So those in Senior 3, you already know this concept of solving linear equations, and for you, your work is to forward the video and go to straight to the assignment. But Senior 1 and Senior 2, you'll need this knowledge. So like I told you, Math Olympiads has 4 parts. There is algebra, integers, or number theory, geometry, and combinatorics. So in this holiday, we are interested in algebra and geometry. So we are going to start with algebra. So this week is all about algebra, and the algebra is just the introduction to algebra. So in your primary, you solved linear equations, and the same knowledge you used is the same knowledge we need. So a linear equation is an equation which contains a variable which is not raised to any power. If you see this, there is no power, there is no power, there is no power. So all these ones are called linear equations. And to solve them, we use what we call inverse operations. So inverse operations are the key to solving the equations as they unwrap all the things surrounding your unknown letter, and leave you with a simple answer. So now we shall call it making this a letter the subject. So this process of unwrapping and isolating a letter to leave it with a simple answer is what we call making a letter the subject. So when you hear me use the word making a letter subject, it means they want you to isolate all the others things surrounding that letter. So inverse operations are just the opposite of each other. For example, if there was a plus, then it means you are going to use a minus. If there was a product, you are going to use a division. And the reverse is true. If there was a minus, you are going to use a plus. If there is a division, you are going to use a product. That's what they mean by inverse operations. And in that way, something will cancel out. So here, in the process of unwrapping or in the process of making a letter the subject, we first look for addition or subtraction and we use that property. And the aim is to collect the variables on one side of the equation and the constant terms on the other. That is the aim for this addition and subtraction. Then after that, we shall look for multiplication or division. And the aim of that is to make the coefficient of the variable term equal to 1. So when there is both a product, if you look at this equation, there is both this here, there is a product, x times 3, but there is also plus addition of plus 7. So the first thing to do is to use the addition subtraction property here by subtracting both sides by 7. Then after that, we shall then use the multiplication or division property to isolate this x. Same applies to this. There is a minus, so we shall first use this property, then we shall go to product. Here there is a division, so this is funny. The first thing to do is to cross multiply, but we shall go to that later. Let's start with part A. Part A, we have that. Then the first step is remember that when a term crosses from one side of the equation to the other, its sign changes. If it was plus, it becomes minus, and if it was minus, it becomes plus. For example, here, I want to make variables on one side and constants on the other side. So I have to take 7 this side, and that's why you see it was plus, it was positive, now it has become negative. It is similar to the concept of primary where they said subtract 7 on both sides. And from there, we realize this cancels, remain with 3x, and here remain with 22 minus 7. So it is also okay, only that now here we are looking at how you can summarize. Should I call it summarize or reducing the number of steps you are to write? So basically that is it. We are trying to reduce on the number of steps to be written. But if you still go with the primary concept, it will still give you the answer. So this minus this gives you 15. Now you have managed to collect like terms. Variables are on one side and constants on the other side. Now next is to isolate the x, and that is done by dividing both sides by 3, because 3 is the coefficient of x. So when you do that, you shall come up with this step and then go to that. Now still, this is what we did in primary, but still it is okay. If you reach there, you just that when I want to take this 3 this side, I remember it was a product, meaning that when it goes this side it becomes a division. So it is also still okay. So you're managing to isolate the x, and that is what they mean by solving for x. That is the rule we shall use for the rest of the parts. This part we are given that. The first thing to do is to isolate. So take this constant, this side, it was positive, it becomes minus. Then simplify or collect like terms. So this gives you 15. Then the coefficient is -5, so we are going to divide both sides by -5 to come up with x equal to -3, because 15 divided by -5 gives you -3, and that's the answer they wanted. Then part C, the first thing to do is each time you see a fraction, the first thing to do is to cross multiply. So in primary, this is what you would used to do. Then you could cross multiply that this with this and this with this. It is okay. Then you could go to that. But in here, you can bypass this step or dividing it by 1. Then also this step and come to this. How? You just say that this one goes this side to become -10, like that. So yeah, we're just trying to see how you can reduce the number of steps, but still primary concepts are the ones being used. So this goes this side to come up with this. Then you divide both sides by 4 to give you that. Okay, then also in primary, used to change an improper fraction into a mixed fraction. Here, it is okay to leave it in an improper fraction. And part D is like that, so take this on this side to give you that, simplify, then take this one here. So we are going to cross multiply, but it's okay to take this on this side to just come up with x equal to -12. But for now, let's do the cross multiplying as it was in primary. But when you get used, you just take this on this side, and that will be the answer. So it is okay to move from this step to this step. And with that, we can go through that exercise. Then now we shall go to equation with repeated unknowns, where there are unknowns on both sides. So equations where unknowns appear more than once need to be solved systematically. And first we have to expand in a bracket, collect like terms, and use the inverse operations. So we shall go through these parts. Part A, there is a bracket. The first thing to do is expand any bracket. So this with this, using the distributive law, this with this, to give you the second step. Then the next step, you are going to collect like terms. Take this 5 this side to give you that. Then simplify, this gives you that, and this gives you this. Then divide both sides. Now I think you realize that here I've skipped a step of where you have to show that this divides by 3 and this divides by 3, and later this cancels with this to remain with x. I've skipped all those steps because it is okay for this level to move from here to here. So when the unknown appears on both sides of the equation, remove it from one side. So here is what we are given, that such an equation. So the first thing to do is to take this on this side and also to become minus 3x, and at the same time take this to this side to become minus 2x. Then you collect like terms to give you that, and this to give you this. Then from there, like I said, it is okay to move from here to the value of x. So take this to this one. It was product, now it becomes division. And that will be the answer. Then part C, we have that to do the same, collect like terms. Take this one this side to give you this, and take this one this side to give you that. Collect like terms, then get the value of x. So with that, you can go through this exercise. And now we shall go to solving equations with more than one fraction. So these can be solved by obtaining the lowest common denominator. So in O level, we use what we call lowest LCM. So this is the same thing, only that now you look for the values in the denominator, and you get their LCM. And that's why you call it lowest common denominator. For the fractions on each side, such that each side has at most one fraction. So actually there are two methods of attempting such a question, but this is the one I prefer. But still, in primary, you learned both methods. So next you cross multiply in order to remove the fraction. So in your primary, you would say the LCM of these two is 6, then you would say multiply each term by 6. By 6. By 6. It is okay, but some students forget to put a bracket here. And remember, we have minus here, we have this negative, and also this negative. So if you forget to put a bracket, then you'll have got a wrong concept. So that's why I prefer that you get LCM on both sides. Because LCM is 6, then 6 divided by 3 to give you 3. Sorry, 6 divided by 3 to give you 2, then 2 times x to give you 2x. Okay, then 6 divided by 6 to give you 1, then 1 times this to give you this in bracket, and this is maintained. So with that, you can simplify. Then you can simplify by saying this, okay, the whole of this is that, then this one goes this side. Then from there, we can now open this bracket to give you minus 1 and plus 2x. And this gives you minus 24. Then this with this gives you 4x minus 1 equal to negative 24. Take this one this side to give you this. So it is okay to move from this step to this step. Then from here, you know that this is the product, so to go this side becomes a division. And it's okay to leave your answer in an improper form. That was part A. Then part B is still the same, get the LCM. So this divided by this gives you 4. 4 times this to give you that. So notice that I'm using the brackets. Don't forget the brackets. Then also 12 divided by 4 to give you 3. 3 times this to give you this part. Then cross multiply, take this 12 this side and open the brackets. And after that, you are going to simplify. This with this gives you 7x. Then this with this gives you minus 1. Then this minus 1 goes this side to give you 13. Then this 7 goes this side to give you x equal to 13 over 7. And that's what they want. Then part C, we are given that. So the first thing to do is to cross multiply, then expand. This with this, minus with minus, positive. 2 times 1, 2. Then collect like terms. This going this side, it was minus 2x, so it becomes 5x. So it is still okay. But in all level, you say plus 2x, then minus 1 is okay, but it's a little longer. Then this goes this side to become 2 minus 1, which is 1. then this goes this side, become 1 over 5. And part D, we're given that still you cross multiply. This with this is 21x, this with this is that. Then expand that bracket, or open the bracket, and collect like terms. So I've taken this one this side to become 11x, here remain with negative 55. When I divide through by 11, I'll come up with x being equal to negative 5. So with that, you can go through this exercise for you to grasp the concept. And now shall go to our second assignment for day 2. I hope the assignment 1 was, you come up with the answers. So like I said, NMC means National Math Contest, then this one is the year, then this one the paper, and the question. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solving simultaneous equations. So if you're not yet subscribed, please click on the subscribe button below this video such that you can receive updates when this video has been uploaded. Also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp such that we can all benefit as a family. Hello viewers, Wadaruna taking you through the story of O-level math contest practice. And this video, we're going to look at the concept of factorization of algebraic expressions. So this video is suitable for students in both Senior 1 and Senior 2 who have the passion of one day participating in the National Math Contest and also in Math Olympiads. So we are now in our day 4. Day 1 we looked at expansion of algebraic expressions, and I left you with an assignment 1. Then day 2 looked at solving linear equations, and I left you with assignment 2. Day 3 was solving simultaneous equations, and I left you with assignment 3. And now we are going to go through the concept of factorization of algebraic expressions, and at the end I'll also leave you with an assignment 4. So in your primary and Senior 1, you looked at this word. So this word HCF is not new, but the difference is that in your primary and your Senior 1, there would be X highest common factor of numbers. For example, they could say 60 and say 45. Then they will ask for HCF of these two numbers. But now the concept I want to bring in is when they bring a variable or a letter. Just as you can see here, we have 6c and here we have 4x squared y. So here we bring in letters. There's a letter c here, there's a letter x here, there's a letter y here. So how do you deal with it? So the same concept is the same as we did for whole numbers. So in the same way that whole numbers have factors, algebraic products are also made up of factors. For example, just as we can write 60 by prime factorizing and it becomes 2 times 2 times 3 times 5, we can also write this as a product by saying 2 x squared becomes x times x, then times y. Okay, therefore to find the highest common factor of a group of numbers, we express the numbers as products of prime factors. The common prime factors are then found and multiplied to give the HCF. I think that concept is familiar to you, only that now we are going to add in when there is an unknown, which we call variables. So let's see how this is done. So we shall go with this example. Example 1 says, find the HCF of the following. Part A is 8a times 12b. I think let's start with that. So 1, you have to prime factorize. So 8, when I prime factorize, it becomes 2 times 2 times 2. So this stands for 8, then times a, which is here. There I have prime factorized. What about 12b? So 12 is 2 times 2 times 3. Then there is a b here. Now HCF means you look for what is common. So there's a 2 in both there. This is also there. These ones are different. So we shall come and see that the HCF is the product of what is common in both, and to be 4. And that's what they wanted in part A. Then part B, you'll come and say 4x squared is 2 times 2, then x squared is x times x. What about 6xy? It is 2 times 3 times 6 times x times y. Then you look for what is common. This is common, okay, and this is common. The rest are not. Therefore, you'll come and say that the HCF is 2 times x, which is 2x. Then part C, this one is the same as 3 times this. So I can't simplify further. Then this one is the same as this times that. Then you look for what is common. You realize that this one is common in both. So it becomes the HCF. So basically that is the concept of HCF which I want you to grasp, because it is going to help us more when it comes to what we call factorization. So we are still on HCF, and I expect you to try out these questions so that you grasp the idea of HCF. Now we can now go to the next concept, which is called factorizing with common factors. So factorization is the process of writing an expression as a product of its factors. This means that factorization is the reverse of expansion. Remember, in lesson 1, we looked at expansion of algebraic expressions. And now we are going to look at the reverse of it, which is called factorization. So in expansion, we have to remove brackets, whereas in factorization, we have to insert brackets. Just as we have here, if I have this, for me to remove the bracket, I'll get this, and that is called expansion. But what if I have this, and I want to insert a bracket? It means it will now become factorization. And I want you to realize something, that what is out here is common to these two terms. Okay, it is the HCF. That's what I wanted to bring out. It is the HCF of 3x and 6. That is what comes here. We shall see how helpful that is. So I think this is what is here. Notice that this is the product of two factors, this and that. Then the brackets are essential, since in this, the whole of this is multiplied by 3, whereas in this, only the x is multiplied by 3. I think we emphasized brackets in that lesson of expansion. So by now you know how important brackets R. Now, to factorize an algebraic expression involving a number of terms, we look for the HCF of the terms and write it in front of a set of brackets. We then find the contents of the brackets. So let's see how that is done through these examples. So example 1, we have this and that. The first thing to do is to find out what are the HCF of those two terms. We have a term of 5x squared and a term of 10xy. And you realize that the HCF, if you grasp the previous concept of HCF, you realize the HCF of this and this will be 5x. Now the rules say that is what we first bring out. So this is how it can come about. You realize this is here and this is here. And the HCF is 5x because this is 5 and this is x. Now bring the HCF outside. So bring this one out to come up with this. Now what is left is what you write inside the bracket. Now here it is only this which is left. That's what you write here. Then you go to the sign which is plus. Now here there is 2 times y. That is why you see here 2y. And you know something? We have factorized. And that is called factorizing completely. So factorize completely means what is outside is the HCF. Let us do the same procedure for part B. Part B, these terms have HCF of 3. Therefore, just as we see here, 3, 3. Now bring it out. What is left here is A, which is this, and what is left here is 2, which is this. So in that case, we have factorized. Okay, let's go to the next. So I believe that by the end of these examples, you'll have grasped the concept behind factorization, but it all starts from identifying the highest common factor. So for these two, HCF is for x. And how does it come about? This is how it comes about. 8 is 4 times 2, 12 is 4 times 3. So 4 is common and x is common. Now when I remove this, I'll bring it outside the bracket. Inside here I remain with 2 times x, which is here. Then there is a plus. Then here there is only 3. And that's what they call factorization. Let's go to the next. So I believe you are now grasping the concept behind factorization. So your HCF is that, therefore. Now here what I've done, usually the question starts with a negative. But it is good practice for you to start with a positive. That's why I have rearranged. Begin with a positive followed by a negative, which gives you this minus 2a. Then you remember the HCF was 2a. Now does it come about? 6 is 2 times 3. Then there is a, there is b. Here it is 2 times a. So realize that 2 is common and a is common. So what is left? Bring that 2a outside. What is left here? There is 3 times b, which is that. Then there is a minus. Then here it is only 1 because all these ones have gone. Then part E, the HCF is that. So you come and write the expression given. So in terms of product, we have this times this times that. Then the common factor is this. So first write it outside. Then inside here, remain with 2, which is here. Then I'll go to plus. Then here, I'll remain with x, which is here. So in that case, I have factorized. So now we shall go to part F. Part F, the terms are those, and HCF is this, because it is one which is common in both. So here I realize that this and this is common factor. So when I first pull it out, which is here, then inside I remain with this, here I remain with x plus 2, which is here. Still the brackets is there. Then I go to this plus, then I'm left with 3, which is here. Now this box bracket is okay, but inside it there is this simple small bracket. So I have to also open this bracket, that small bracket, to become x plus 2 plus 3, which is now x plus 5 when I collect like terms. And in that case, I have factorized. So basically, that is the concept behind factorization. And I encourage you to go through these questions. Now we shall go to another format of factorization, and that is called difference of two squares factorization. Now this word difference, the word difference in math, it means subtraction. So difference between a squared and b squared is written as that, and it is known as difference of two squares. Now the question is, how do you factorize it? For you to understand it, let's first go back to expansion. What if I want to expand this? You realize something funny, that is equal to this. So I encourage you to try out how to expand this, because we already saw in video 1 that expanding this gives you first put a outside, then a minus b. Then you go to this plus here, then put b outside, then again a minus b. So when you expand and simplify, you realize that you come up with this, and I think that's what this next step is all about. This a times the whole of this b times the whole of this, then you open this bracket, a times a squared, a times b minus a b, b times a, ba, then b times b minus b squared. Then this cancels, and you remain with this minus that, which is here. So you have come up with an expression similar to this, which is called difference of two squares. But where has it come from? It has come from this. Meaning that is the concept behind factorizing difference of two squares. So each time you see difference of two squares, the factorization should have one bracket with a sum, another bracket with a difference. But this is not the case if it was sum. If it was a squared plus b squared, then that one, there's no way you can factorize it. The formula factorization is only for difference of two squares. So with that, we can go through these questions. So part A, it is 9 minus x squared. Now it is up to you to be able to identify that this one is a square number, and it is got from 3 squared. So I'll come and first write what is given, then I change 9 is the same as 3 squared. Now here it is difference of two squares, so I can use this whereby one bracket has sum, another bracket has difference of these ones, 3 and x, and that is called factorization. Then part B, still I realize that this 2 is 2 squared, 4 is 2 squared, and 25 is 5 squared. And I think we already saw in the previous slide, I recall that if it is x squared times y squared, it is the same as x times y everything squared. So that's what I've done here. So that difference of two squares, it means I'll get the sum of 2x and 5, and also the difference of 2x and 5. And there I will have factorized. Then part C, we have that. Now here, this is not a perfect square, but we can realize that these two have a highest common factor of 2. So I'm going to first factorize out 2. I remain with x squared here. Here 8 is 2 times 4, so I remain with 4 here. Then from there, this 4 is now a square number, so it becomes 2 squared. Then I'll simply deal with this. I'll first write 2, then get the sum of x and 2 and the difference of x and 2. And that's what they wanted in part C. Then part D. Part D is a little tricky, but still you are going to first factorize because the HCF is A. So pull it out, here remain with x power 4, and here remain with 1. Now this one is funny, because any number to power 1 to power any number, the answer remains 1. So that is why it is okay for you to write this as 1 squared, so that the concept of difference of two squares can come out. Then your difference will now be for x squared and 1, which is sum and product and difference. But still this one, you will still have a square here. So again, write this as 1 squared to still get the difference and sum. So sum of x and 1, difference of x and 1. Now there we have finished, because we already saw that the sum of two square numbers of two squares does not factorize. Part E. Part E here, like we said, it is advisable to start with a positive. So I'm going to start with 48, then minus 3x squared. Now this is not a square number, so what we do, but the good thing, there's an HCF between these two terms. So that's what I'm going to first pull out, and I factorize. So here it remains with 16, here it remains with x squared. Now 16 is a square number, it comes from 4 squared, so I can easily factorize it. 4 and x sum, 4 and x difference. Then part F, we are given that, still change 9 to 3 squared. Now difference of two squares, still it will be this, the whole of this bracket with 3, which will have sum and also a difference. But inside this box bracket, there's another small bracket which I have to deal with. So let me expand and remove it. Then I can simplify to give you this and that. And there I have factorized. Then part G, I have that. So still difference of two squares. The sum is now for 2x plus 2 and x minus 1. Sum difference. Then I'll deal with this inside brackets to give you that and that. Then collect like terms. This with this, 2x, this with this, plus 1. This with this, x cancels, then this with this, it is only 3. So at the end, you have that as the answer. So with that, I encourage you to also go through these questions so that you come up with you grasp the concept of difference of two square factorization, because someday you'll need it in the math contest and also probably in the math Olympiad. Now we shall go to the next part, because we have been dealing with factorization involving two terms. But what if they are 4 terms? So some expressions with 4 terms do not have an overall common factor, but can be factorized by pairing the 4 terms. So you pair to 2. For example, if you look at this, when I pair these 2 first alone, I'll realize that A is common in both, and here D is common in both. So I'll come and pull out A, here remain with B plus C. Pull out D, I'll remain with B plus C. Okay, now after that you realize something interesting is that this bracket is the same in both terms. So I'm going to first pull it out, then here remain with A plus D. And in that case, I will have factorized completely. So basically, that is the knowledge you're going to use in this next examples. So for example, factorize completely the following. So let's start with part A. Now part A, we are given that. And you can begin by pairing these two alone and these two alone. So when you pair, you realize that here there is nothing common, and also here there is nothing common. So what does it mean? It means that you can rearrange these terms so that you get a pair with something common. So when I rearrange by bringing this B here and this D goes here, I'm going to come up with this line. Now this line, you realize that now the first pair has something common, which is B. And the second pair has something common, which is D. That is if I've brought this B here and this one went here. But what if I brought this one here and this one went here? This is where this alternative approach comes in. And with this 3A is the one which is common here. And here what is common is only 1. So any pair I want is okay. I can choose to go with this or to go with this. It is still okay, provided there is a common factor somewhere. So if I go with the first one, the common factor was B, so pull B outside, I remain with 3A plus 1. Pull D outside, I remain with 3A plus 1. I think realize that this bracket is similar to this. Okay, that is what you should always look for. Then what if we chose this approach? A3A is common, so I remain with B plus D. And here I remain with B plus D. So still, you realize that this bracket is similar. So that is what we are interested in. Then from there, because they are similar, I can pull it out. Pull this one out. I remain with B plus D. For this case, I'll pull B plus D out. I remain with 3A plus 1. And in either way, I have been able to factorize. That was part A. Then we shall go to part B. Part B, we are given that we are going to pair. Here, X is common, and here 5 is common. So pull out X here, I remain with 1X here and 2 here. Here pull out 5, I remain with 5, and here I remain with 2 because 10 is 5 times 2, but 5 is here, so I remain with 2. Then we realize that this bracket is similar, so always they must be similar brackets. So pull it out, you remain with X here and 5 here. And in that case, you have factorized. What about part C? Part C, you're given that still the same pair. Okay, now this pairing is funny because in the previous video it was plus plus, but here there is minus minus, so you need to be keen. So in the first part it is X which is common. Second part there is negative 4 and negative is negative 4 which is common. Because this is negative 4 times 1 and this is negative 4 times 3. So this one, remove out X, I remain with 1X here and 3 here. Remove out negative 4, I remain with X and positive 3 because the negative has moved out. Negative 4 times 3, the negative 4 has moved out, so I remain with only 3. The brackets are the same, so we are on track. So bring them out and then write the balance. The balance here is X minus 4. That was part D. Then part C, now part D. So the same, you look for what is common, then factorize out. Then this bracket is similar. That's what we are interested in. bring it out, the balance is x minus 1. So in that case, I will have factorized. So I'll leave you with this exercise for you to try out on this part so that you grasp the concept. Okay, now we shall go to the long awaited. So all along I've been targeting this part, which involves factorizing quadratic trinomials by splitting the middle term. So this splitting the middle term is the part which already disturbs, but today we shall look at it. So a quadratic trinomial is an algebraic expression of the form this, where x is a variable, a, b, c are constants, and a is not equal to 0. Now to factorize such, we bring in this thing called splitting the middle term. But how do you split the middle term? You have to follow these procedures. So given this expression, you are going to first get the product of this coefficient of x squared times the constant to give you this. That is step 1. Step 2, find the factors of SC, of the product you have got, but whose sum is equal to b. The factor of a times c whose sum is equal to b. That is what we want. So when you get those two factors, so let's assume, because the unknowns, if these factors are p and q, it implies that where there was b, you are going to put there p plus q to become px plus qx. Okay, when that is done, you can now complete the factorization, because we have now got 4 terms, and the previous slide we saw factorization of 4 terms. So the tricky part with this is that these are 3 terms, so that you have to look for a way of making them 4 terms by following step 2 and step 3. Then step 5, sometimes they can tell you to solve. So when they want you to solve a quadratic equation means here they say equal to 0. It means that you will equate the factors to 0. And that means that there will be 2 values of x, as we shall see in the worked examples. So now we shall go through these questions, but it says factorize completely and hence solve. So here it is not, there's no equal to 0, here there is equal to 0, meaning here you can solve, but here you can only factorize. So let's start with part A. Part A, they gave you that. So you're going to look for, first of all, get this product. This with this, it gives you 30. So we're going to look for factors of 30 whose sum is equal to 17. So let's try to look for them. 30, we have 1 times 30, but when you add, you get 31, so it is not okay. You cross that out. Next factors, we have 2 times 15, but when you add, you get 17. So this 17, I think realize it's here. So these are the factors they want. So come and see that the factors are 2 and 15. Okay, then remember the next step. The next step was replace this 17 with 2 plus 15. But because there's an x here, it's going to have become 2x plus 15x. And now you have succeeded in getting 4 terms, meaning you can use the knowledge already known to factorize. First is group 2. So for this first 2, the common factor is x. For the next 2, the common factor is 5. So factorize out x in the first 2, you remain with 3x and here 2. Factorize out 5, you remain with 3x and here 2. So now here I realize that these brackets are the same, so you can first pull it out, then you write the remainder. Here there is x and here there is 5, and in that case we have factorized. Now realize something, that here I've used 2 first, then 15. What if it is 15 and here I put 2, so that 3x squared is paired with 15 and 2x is paired with 10? You'll still come up with the same answer. So let's try that as an alternative, where 17 is replaced with 15x plus 2x. So in that case, I'm going to pair these two to give you a common factor of 3x, and these two to give you a common factor of 2. Then I'll pull out the 3x here, I'll remain with x, and here I'll pull out 3x, I'll remain with 5, because 15 is 5 times 3. That's why I remain with only 5. Here, pull out 2, I remain with x, and here I remain with 5. Still, the bracket is the same, so bring out the bracket, then here the remaining part is 3x, and here the remaining part is 2. So in that case, I have factorized. Let's go to the hence part they wanted us to solve. Now we have realized that this is equal to this. Okay. So I'm going to come and replace where there was this, I'll put there this 1 because I factorized it. But because it is equal to 0, even here I'll put equal to 0. Then remember what we wrote in step 5 is that each term you put 0. Because for you to get a 0 here and it's a product, one of them should be a 0 or both. So either this is a 0 or this is a 0. That's what I shall write here. Then for this one, it means that bring this 5 this side to come up with x equal to negative 5. Then you bring the 2 this side, we come up with 3x equal to negative 2. Divide both sides by 3 to give you negative 2 over 3. And those are the values they wanted. So now I shall go to part B. Part B, you're given that expression. So the first thing to do is to look for factors of this times this. Factors of negative 4, whose sum is equal to 3. So you come and also look at them. 1 times 4, the sum is 4. What if it was negative 1 times 4, the sum would be 3. So these will be the factors. So the factors are negative 1 and 4. So come and write this, then replace this 3x with negative 1x plus 4x. Then you pair the 2. This one, the common factor is x. Here the common factor is 2. So here pull out x, you come up with this. Here pull out 2, you come up with this. Now this bracket are the same, so bring them out and write the balance. The balance is x plus 2. And there you will have factorized. But for the hence part, it was equal to 0. So equate the factors to 0, meaning that each can be 0. For this equal to 0, take this one this side. For this one, take this side to come up with that. Then to make x the subject here, divide both sides by 2. So those will be the values they wanted. Then for part C, given that still the sum is negative 11 and the product is 6 times negative 10, which is negative 60. So if I start with 1 times negative 60, the sum is negative 59, which is known this. What about 2 times negative 30? The sum is negative 28, is known that. What about 3 times negative 20? The sum is negative 17, not yet. But 4 times 15, but times negative 15, the sum is negative 11. So we take these as factors. Then you can come and split the numerator, split the middle term. And then look for the common factor of each pair. Here the common factor is 3x, here it is 2. So 3x here, remain with 2x here, and remain with 5 here. Here, remove 2, I'll remain with 2x, remove 2, I'll remain with 5. Then write this bracket because it's the same in both, so you first write it, then write the balance here and that. Then for the hence part, equate to 0, and you'll come up with that or that. Then take this one this side, and also this one this side to come up with this. Then here, divide both sides by 2 to get this, both sides by 3 to get that. And that's what they wanted. Then part D, we are given that, still do the same procedure, product, sum, then look for the factors. So that gives you sum of that, which is not what we want, and this gives a sum of -8, and that's what we want. So the factors are -3 and -5. Then come and split the middle term. Then pair. Look for the common factor for each pair. Here the common factor is x, common factor is -1. So x, remove x here, remain with 5x, remove x here, remain with 3. Remove -1 here, remain with positive 5x. Remove -1 here, remain with -3. Then this bracket is the same, bring it out, here remain with x, here remain with -1. They will have factorized. Now for the hence part, you have to equate to 0. So take this side and also this one this side to come up with this. Here divide both sides by 5 to come up with those two values of x. Then part E, we have that. So here the good thing, all the 3 terms have a common factor, which is 2. So first pull out the 2. Then this bracket inside, we shall look for the 2 factors, because we have to split this middle term. The factors whose sum add up to this. So factors of 90, whose sum add up to -19. And we realize the factors are -9 and -10. So come and split the middle term and group in each pair, this and that. So here the common factor is 3x, here the common factor is -2, meaning that here this remove 3x will come up with 5x. Here remove 3x will come up with 9. Here remove 2 you come up with 5. Remove -2 you come up with positive 5x. Remove -2 you come up with -3. Then here the brackets are the same, so pull it out, which is this. Then the remaining part is this minus that. So in that way you will have factorized. Then you have got the hence part where you have to equate to 0. So these two can count. When you go to the side 0, divide by any number 0. That's why you get this. Then each term can be equated to 0. Like that, then divide here both sides by 3 and here both sides by 5. And that's what they wanted. Then part F. So there's something common in all, and that is 5. So that's what you first pull out. Then you look for factors of -8 whose sum is -2. And those factors will be 2 and -4. Then split the middle term and then factorize each pair. So here 4x is common, you remain with 2x here, and here remain with 1. Here remain with 2x and here 1. So these brackets are the same, so pull it out, you remain with 4x here and -1. And that's how they can factorize. Then for the hence part, you equate to 0. And you'll be able to get the values of x as that. So I believe now you can try out this exercise for you to grasp the concept behind factorization and solving quadratic equations by factorization. Now, there are some quadratic equations which are not easy to factorize. In that case, we come up with what we call a quadratic formula. So this quadratic formula works for any quadratic formula equation, where the quadratic equation can be factorized or it cannot. The quadratic formula can work. So the formula states that if this is the quadratic equation, then the values of x can be got from from negative b plus or minus. Now we're using plus or minus because there will be two values of x, just as you have seen in the previous slide. Square root of b squared minus 4ac, everything divided by 2a. So when you use that formula, you still come up with the two values of x which they want. But there's something we need to note here about this quadratic equation. If this is greater than 0, then it means that you are going to get two distinct values of x. But if it is equal to 0, it means you'll get only one value of x. And if it is less than 0, you will get no value of x because negative square root is undefined at our level. So with that, we are going to use the formula to go through this question. Now, these are some of the questions which you have already done using the method of factorization. But now I want to ask myself, if I use the quadratic formula, will I get the same answer or not? So let's start with part A. Part A, we are given that. Then you come and remember the general formula for a quadratic equation. Then you compare. It means A is 3, B is 17, and C is 10. Then I'll come and recall the formula and then substitute. B was 17, so negative B is negative 17. B is here, it is squared 4 times A times C, which is 10, over 2 times A, which is 3. Then now it is now the power of a calculator, because 17 squared is this, and the whole of this is this. Then when you subtract these two, you come up with 169. Then you get the square root of 169, you come up with 13. So that you have two options. You can first use a plus and then you also use a minus. When you use a plus, come up with this. Use a minus, come up with this. So the one who use for a plus, actually this is some statement and ignore. For a plus, this is negative 4 and here it is negative 30. Then you simplify the fractions to come up with that and that, which are the same as before. Then for part B, still you do the same, get the values of A, B, and C, then code the formula and substitute. Substitute for B, A, C, and A. Then now use a calculator. This is 9, and all of this is negative 16. Negative with the negative gives a positive. Then 2 times 2 is 4. Then this gives you root of 25. Square root of 25 is 5. So you can use a plus or a minus. For a plus, come up with this. For a minus, come up with this. Reduce the fraction to come up with that. Then part C, you have that. Still follow the same procedure. Get the values of A, B, and C. Then code the formula, substitute. So substituting, here B was negative 11, but here we have negative B, so negative of negative 11. Here is negative 11, A is 6, C is negative 10, A is 6. Then simplify. When this one negative is positive, then here negative 11 everything squared is 1 to 1. Then the whole of this is negative 240. Now negative with this negative gives a positive. Then 2 times 6 is 12. Then use a calculator, simplify this to give you root of 361. And square root of 361 is 19. So here you can use a plus, here is a minus. When I use a plus, I get that, minus, I get that. Reduce the fraction to come to that. Then part D, I hope you are getting the concept behind using the quadratic formula. So get the values of A, B, and C, code the formula, and substitute. Then simplify. This is 64, the whole of this is 60. Simplify again, this gives you square root of 4, which is 2. So when I can use plus and minus. Plus, I get that, minus, I get that. Simplify to get that. So you can go through that exercise for you to grasp the concept. And now you can start. I'm going to leave you with an assignment 4, like I told you at the start of the video. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solution to the math contest assignment 1. So then if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family. Hello viewers, Wagdaruna taking you through the story for O-level math contest practice. And this video I'm going to go through the possible solutions to the math contest assignment 1, which was posted earlier. So I think you remember that in this week, in day 1, we left an assignment 1 in that video for expansion of algebraic expressions. So now that we are in day 5, we are going to go through the solutions for that assignment 1. And so later in the day, we shall go through the solution for the assignment 2. So these were the questions, and we shall now see how you were supposed to answer them. So question 1 was got from the National Math Contest of the year 2019, paper 1, question 1, and says, if we mix 1 liter of lemonade that contains 4% of lemon with 2 liters of lemonade that contains 10% of lemon. What is the percentage of lemon in the resulting 3-liter mixture? Now here we know that the total lemon in the mixture is equal to the lemon which was in the 1 liter plus the lemon which was in the 2 liters. So the 2 liters and the one which was in the 1 liter. And by the one in 1 liter, they say it was 1% of this 1 liter. So 0.4% is 4 over 100 times what? Times 1 liter. Then here it was 10%, which is 10 over 100 times what? Times the 2 liters. So we shall get the total number of liters of lemon in the mixture. So this one gives you 0.04 and this one gives you 0.2. When you add the two, you get 0.24 liters of lemon. Remember, we have a mixture of 3 liters, but 0.24 are lemon. Now they ask, what is the percentage of lemon in the resulting mixture? Remember, percentage of something is, for example, percentage loss can be percentage increase is increase over original times 100. So even here, percentage of lemon is the liters of lemon over the total times 100. Now, what is the total mixture? The total will be the 1 liter plus the 2 liters to give you 3 liters. Therefore, percentage is the liters of lemon over the total liters times 100, and then you come up with 8%. So basically, that is what they wanted in this question. Then question 2, it came from the National Math Contest of 2017, paper 2, question 8, and it says, a liter bottle of a liquid contains 10% alcohol and another 3-liter bottle full of liquid contains 30% alcohol. They are mixed together. What percent of the mixture is not alcohol? Not alcohol. So we shall follow the same procedure as we have done before. Total alcohol in the mixture is equal to alcohol in 1 liter plus alcohol in 3 liters. So for 1 liter, they say 10%. So 10% is 10 over 100 times 1, which is 1 liter. 30% is 30 over 100 times 3, which is 3 liters. So get the total number of liters of alcohol, which is 1 liter. Then the total amount of the liquid is 1 plus 3, which is 4 liters. So the question said percent of the mixture which is not alcohol. So this was for alcohol in the mixture. This is a total mixture, meaning that the one which is not alcohol is not by subtraction, which is now 3. Therefore, the required percentage would be 3 over the total times 100 to give you 75%. Question 3 came from National Math Contest of 2016, paper 2, question 5, and says, a student takes 3 exams. The second has twice as many questions as the first, and the third has 3 times as many questions as the first. The student answers exactly 75% of the questions correctly on the first exam, exactly 81% on the second exam, and exactly 85% on the third exam. Out of all the questions on the 3 exams, what percentage did he answer wrongly? Okay, now here we have 3 sets of exams. We shall first tabulate. So this contains all the questions, then some are correct and some are wrongly answered. Now here they told us that there are 3 exams, that's why you have test 1, test 2, test 3. Then the second is twice as many questions as the first. So if the first one is x, the second one will be 2x. Okay. The third has 3 times as many questions as the first. So if the first one is x, the third will have 3x. Okay. The student answers only 75% of the questions correctly on the first exam. So here, the ones which are correct are 75%, which is 0.75x. Exactly 81% on the second exam. So here, the ones which are correct are 0.81x. Okay, the balance will be total minus this one which are correct together ones which are wrong. Then here, they said 0.81 times 2x to get the number of questions which are answered correctly. Then the ones which are answered wrongly will be the balance, 2x minus this. Then here they said exactly 85, which is 0.85 times 3x to give you this. And the ones which are wrongly answered are the balance, which is this. Now the question said, what percentage did he answer wrongly? Now percentage for wrong is number of questions which are wrongly answered over the total number of questions multiplied by 100. So the number of questions which are answered wrongly, there is this plus this plus this. Then the total number of questions, we have this plus this plus this. So we're going to divide the 2 and multiply by 100. Then we simplify. So here this can cancel with this. Then when you use the calculator, 1.08 times 100 divided by 6 gives you 18%. And that's what they wanted. Question 4 came from the National Math Contest of 2012, paper 2, question 3. And it says, 2 fractions are removed from the following 6 fractions, so that the sum of the remaining 4 fractions is 2 over 3. What is the product of the 2 fractions that were removed? So this was a little tricky. Now what we are going to do, we are going to first add all the 6 fractions. And what does it give? So here LCM we shall get 180. Now 180 divided by 3, it gives you 60 times 1, which is this. 180 divided by 6, it gives 30 times 1, which is this. Do the same until you get all these values in the numerator. So when you add all the values in the numerator, you'll come up with 147. We shall first leave it like that without reducing. Then they told us that 2 fractions are removed from 6, so that the sum of the remaining ones, 4, is this. Now this is the sum of all the 6. This one is the sum of all of the 4. Meaning that when I subtract the 2, I will get the sum of the 2 fractions which were removed. So I'll come and say that sum of the 2 fractions which were removed will be got by subtracting this from this, which is here. Get LCM and then simplify. So 180 divided by this is 1 times this is 147. 180 divided by this is 60 times this is 120. So subtract the 2, you come up with 27. Okay, now what you're going to do in these ones, Are there pairs which can give a sum of 27? Let's try to see. This one was already off because this is already above 27. This one is off. This one is also, this one is still there. Now this one, can it be added with anything else? Because if I add with this one, it is above 27. With this, it is 32, which is not. With this, it is 30, so it is also off. So this is off, off, off. What about this? This with this, it gives 27. And think it is the only one. So what we are going to do, we are going to come and say, where did it come from? Remember, this one came from this one came from this one came from this one came from this, and this one came from this. So these are the two fractions of interest. So it was some good logic. So the two fractions here removed are those ones, these ones here. But the question wants their product, meaning I'll come and multiply the two and get the answer which they wanted as 1 over 180. Then question 5 came from National Math Contest of 2012, paper 2, question 11, and says, two men, Liam and Awad, went for a drink. Awad took a cup filled with water and drank a fifth of its contents. When he looked aside, Liam refilled the cup by adding alcohol and then stirred. Awad drank a quarter of the mixture. Okay. When Awad again looked aside, Liam refilled the cup with more alcohol and stirred. Awad drank a third of the mixture. When Awad looked aside for the third time, Liam still refilled the cup with more alcohol. What percentage of the final mixture was alcohol? So this was also tricky in its own way. So the words are too many. What you're going to do, we are going to follow statement by statement. Let's start with the first one. First one, you have two people of interest, Liam and Awad. Then two, they told us something that Awad took a cup and filled it with water and drank a fifth of its content. So let's try to illustrate that. We have a cup. It was initially was full of water, but now he drank a fifth. So this fifth is empty. And the part fraction which has water is 1 minus a fifth, which is 4 over 5. Okay, that is this statement. Then shall go the next statement. Next statement says, when he looked aside, Liam refilled the cup by adding alcohol and then stirred. So this empty space was now filled with alcohol. So I'll come and say that the illustration is now in this form, where we have water and alcohol. And alcohol is the same fraction as before here. And water is still this fraction. That is the second statement. Then we shall go the next. Awad drank a quarter of the mixture. Remember, the mixture now has alcohol and water. So if he drinks a quarter, it means that the remaining part is now a third, and comes from 1 minus a quarter. So a third of the 3/4 of the mixture. So 3/4 of alcohol plus water is what is left. So we have what is left with 3/4 of alcohol, which was initially there, and also 3/4 of water, which was initially there. So we shall come and ask ourselves, what is 3/4 of this? And what is 3/4 of this? So this is what was drunk. a quarter of the mixture. Then here we have 3/4 of 1/5 to give you 3/20. And here we have 3/4 of 4/5, which is that. Okay, now that is what you have so far, but the statements are not yet done. So let's go to the next statement. Next statement says, when Awad again looked aside, Liam refilled the cup with more alcohol and stirred. Now notice something. Refilled with alcohol, meaning that the mixture, okay, the fraction, this space is going to be filled with only alcohol, meaning that this fraction here of water is still the same as before. Now, because it is still the same as before, we are going to make this sketch and say that the fraction of water is still the same, which is 3/5. Now, the one for alcohol is the balance, which is 1 minus 3/5, and gives you 2/5. Okay. Then the next statement, Awad drank 1/3 of the mixture. So that means that the balance will be 2/3 of the mixture, which is 2/3 of alcohol and 2/3 of water. So I'm going to come here and make another sketch where there is water, alcohol, and an empty space. So the empty space is 1/3 of the mixture, which is that. Then for alcohol, it is 2/3 of what was initially there. And for water, it is 2/3 of what was initially there. Okay. That is for that statement. Then shall go the next statement. Next statement says, Awad looked aside for the 3rd time, and Liam refilled the cup with alcohol. So the content, the fraction of water is still unchanged here. So we shall come and draw another sketch. So we have that fraction of water. Then the balance will now be alcohol, which is 1 minus 2/5. Now the question is, what percentage of the final mixture is alcohol? I think you know percentage of alcohol means alcohol over the total times 100. But the good thing here, we already know the fraction of alcohol, so we shall just get this fraction and multiply by 100. So required percentage will be 3/5 times 100 to give you 60%. And basically, that is what they wanted. So that brings us to the end of this video. Thanks for watching, and bear in mind that the next video will be on solutions to assignment 2. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so they can all benefit as a family. Hello viewers, Wagaruna taking you through the story for O-level math contest practice. And this video I'm going to go through the possible solutions for the math contest assignment 2, which was posted earlier. So remember, in day 2 we looked at the video of solving linear equations and I left assignment 2. So in this video I'm going to go through the solutions to that assignment. I believe by now you have attempted those questions. So question 1 came from National Math Contest in the year 2011, paper 1, question 6, and it says, Joshua was 3 times as old as Janet in 1993. Okay. In 2001, Joshua was 8 years older than Janet. How old is Janet now? In other words, how old is Janet in 2001? So we shall come and tabulate and put Janet and Joshua. Then they told us here, the statement says, Joshua was 3 times as old as Janet in 1993. So I'll come and say that in 1993, if Janet is X years old, then Joshua will be 3x years old. Okay, then that was the first statement. Second, they said in 2001, Joshua was 8 years older than Janet. Now in 2001, if you are to count, those are 8 years added. So it means that here we shall add 8 years, and also here we shall add 8 years. So if they want the age of Janet now, they want the value of x plus 8. But the good thing, they have told us that in that year, Joshua is 8 years older than Janet. So the age of Joshua will be equal to the age of Janet plus 8. That's what that statement means. So I'll come and put the age of Joshua equal to the age of Janet plus 8. Then you can solve, because these are linear equations, open brackets, collect like terms, brings on this side and this on this side, divide both sides by 4 to get 4 years. So now that I have the value of x, I can get the age of Janet, which will be x plus 8, and that will be 12 years. So basically that is what they wanted. Then question 2 came from National Math Contest of 2010, paper 1, question 5, and says, at the end, note this word, end of 1994, Walter was half as old as his grandfather. Okay. The sum of the years in which they were born is 3838. How old will Walter be at the end of 2010? So still we shall come and tabulate for us to interpret the question. So we have grandfather, we have Walter, we have the total. Because they told about this word sum, that's why we'll add the column of total. So at the end of 1994, if the grandfather, because here they told us that Walter will be half as old as the grandfather, meaning that if the grandfather is x, Walter will be a half x. But to avoid working with fractions, we are going to let the age of the grandfather be 2x, so that Walter's age is x. Okay. Then the total, the sum of their ages is 3x. Because when you add 2x plus x gives you 3x. What about at the year of birth? So the year of birth, when the year of birth, here it will be 1994 minus 2x. And here it will be 1994 minus x. Then when we add the 2, this plus this gives you 3988. Then you have minus 2x minus x gives you minus 3x. Okay. But they told us something, that the sum of the years in which they were born is 3838. So I'm going to get this one and equate it to this to get a linear equation. Then look for a way of making x the subject. The first thing is to take this one this side to come up with this, then divide both sides by 3 to come up with 50 years. So that is the value of x. But they told us, how old will Walter be at the end of 2010? So in 1994, Walter is 50 years. How old will he be in 2010? So I'll come and say that 50 plus the additional years from 1994 to from 1995. Why? Because this year is at the end of 1994. So starting from 1995 up to 2010, those are the years which are added, and they are 16. So 16 plus 50, you come up with 66 years. So that is the age of Walter in 2010. And that's what they wanted. Then question 3 came from National Math Contest of 2012, paper 1, question 11A. And it says, a jeweler has a 20-gram ring that is 60% gold and 40% silver. He melts it and adds enough gold to make it 80% gold. How many grams of gold should be added? So I think remember the formula that percentage increase is equal to increase over original times 100, or increase over total times 100. So initially, the quantity of gold in the mixture was 60%. So it was 60 over 100 times 20 to give you 12. That was initially. Then they said he keeps on adding gold so that the percentage becomes 80. So shall let X be the extra quantity of gold added in the mixture. Therefore, the new amount of gold will now be initial amount, which was 12, plus the X which has been added over the total. Initially the total was 20 grams, but remember you kept on adding until you added X grams of gold. So the total quantity is now 20 plus X. So when you apply this by 100%, you must get 80%. Okay, we have come up with a linear equation. Now next is to solve it. What I'm going to do first is to take this 100 this side to become 80 over 100 to give you 0.8. Then I can cross multiply this with this to give you this. Then I can open brackets. And after opening brackets, this with this gives 16, this with this gives 0.8x. Now I can collect like terms. Bring this on this side, so 1 minus 0.8 is 0.2x. Then this one this side, 16 minus 12 is 4. And divide both sides by 0.2 to give you 20 grams. So that is the additional grams of gold added. And that's what they wanted. Then question 4 came from National Math Contest of 2010, paper 1, question 6. And it says, each day, Jesse ate 20% of the mangoes that were in his fridge at the beginning of that day. At the end of the second day, 32 had remained. How many mangoes were in the fridge originally? So shall come and say that let M be the total number of mangoes originally in the fridge. Okay. Remember, they want the mangoes which original. Here they've talked about the ones which have remained. But they have given us the percentage of mangoes eaten. So what you are going to do, first get the percentage of mangoes which remain, and to be 80%. So I come and say that remaining mangoes at the end of day 1 will be 80 over 100 times M to give you this. Now these ones are the ones which remained in day 1. Now in day 2, he came and also ate 80% of these ones which had remained in day 1. So remaining mangoes at the end of day 2 would be 80% of these ones which had remained in day 1. To give you 0.64 M. Now they've told us something, that these ones remained in the 2. So this should be equal to this. Let us equate the 2 and we see. We have a linear equation, so to make m the subject, I'll divide both sides by 0.64 and m will be 50. So you'll come out that originally there were 50 mangoes in the fridge. Question 5 came from National Math Contest of 2017, paper 2, question 11. And it says, in a group of 5 friends, the sums of the ages of each group of 4 of them are this, and that. What is the age of the youngest friends? Youngest of the friends. Now this one required some logic also. So you're going to let the ages be x1, x2, x3, x4, and x5. Now these are inequalities to mean that this is the youngest, followed by this, followed by this, followed by this, and this is the oldest. Okay. But they said these sums, you keep on adding 4. But if you realize they are in ascending order, meaning this is the sum of the first 4 which are youngest, and these are these ones. So we shall come and say x1 plus x2 plus x3 plus x4 is 125. Okay. Then next, we'll now remove x4 and replace it with this to give you this sum. Okay. Then next we shall remove, here we removed x4. Then here in the next one we are going to remove x3. So x3 was removed and we got the other sums. Then next we are going to remove x2 and get the sum of the other 4. And lastly we shall remove x1 and get the sum of the other 4. So these are the sums which are given here. Now the question says, what is the age of the youngest of the friends? Do you know what they want? They want this one, the value of x1. Good enough, we have already covered simultaneous equations in lesson 3. So what I'm going to do, I have to look for getting x1. The first thing to do is to add all the equations. When I adding, this is what I'm going to come up with. It is a little funny, but I'm going to explain it. If I add all these ones, how many x1s are there? There is x1, 1, 2, 3, and 4. So there's 4x1. What about x2? 1, 2, 3, and 4, which gives you that. x3, there is 1, 2, 3, and 4, which gives that. Then x4, there is 1, 2, 3, and 4, which gives that. And x5, there is 1, 2, 3, and 4, which gives that. So that is why what I did, I factored out 4 because 4 is for all. We have 4x1, 4x2, 4x3, 4x4, and 4x5. That's why I pulled it out. Okay, that was this side. What about this side? When I get a calculator and add all these ones, I realize that I'll get 664. Okay. Now, next step is to take this 4 this side by dividing both sides by 4. I'll come up with that. So 664 divided by 4 gives you 166. Now, because they want this value of x1, I'll come and say, this remaining part, what is its value? I'll compare it with this. Do you realize something? This and this, don't you think they are similar? Because here it has x2 plus x3 plus x4 plus x5. What about here? It also has x2 plus x3 plus x4 plus x5. So the whole of this sum is equal to 142. Therefore, I'll come and replace it with 142. To give you that. Now, is there a way of making x1 the subject? Of course, by taking this one this side to give you x1 as 24. Therefore, the age of the youngest is 24 years. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solutions for the assignment 3. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family. Hello viewers, Wagaduruna taking you through the story for O-level math contest practice. And this video I'm going to go through the possible solutions to the math contest of assignment 3 for the year 2023. So the assignment was already posted previously, and now we are going to go through its solution so that you can check your progress. So question 1 came from your National Math Contest for the year 2019, paper 2, question 14, and it says, 3 gamblers went into a betting shop. At the start of the betting, they had money in the ratios 6, 5, 4. And at the end, their money was in the ratios this 7, 6, 5. One of the gamblers won 30,000 shillings. How much money did he have at the end? So this was a little tricky. It was not the normal ratios we are used to, which we covered in primary. So what you're going to do, we're going to first get the total ratio before betting. It was this, so add to get 15. What about after betting? It was this, so you add to get that. Then we are going to multiply the two ratios to come up with 270. Now, why are we doing that? It is because the total money involved in the process of before and after betting should be a product of the two ratios. Therefore, we can now come and say that let the money be 270x, which was involved in the whole process. Okay, now with that, we can draw our table and try to analyze what transpired. So we have 3 gamblers, and here is a column for amount before betting, amount before betting, and the comment. The comment is where they made a profit after, or a loss, or neither profit nor loss. So that's what we want to analyze. Let's start with first gambler. The ratio was 6. So 6 over the total ratio times the amount. When you multiply, you come up with 108x. Okay. What about the second gambler? It was 5 over the total ratio times the total amount to give you this. Then the third, it was 4 over the total ratio times the total amount to give you that. That was before betting. Then after the first gambler, it was 7 over the total ratio times the total amount to give you that. And the second one, it was 6 over the total ratio times the total amount to give you that. And the third one, still ratio over the total amount times the total ratio times the total amount to give you that. Okay, now we should analyze. Here it was initially 108x and now it is 105x. Something has happened and that is a loss. Here it was 90x and here also still 90x, meaning that neither loss and nor profit. For this it was 72x and here it is 75x. So something happened and that was a profit. Now, and remember in the question, if we go back here, they said one of the gamblers won, meaning they made a profit of 30,000 Ugandan shillings. And here the good thing is that there is only one person who won, and that is the third gambler. So that means that the 30,000 shillings he won is equal to 3x, meaning that when I equate the two, I can get the value of x. After getting the value of x, they told us something in the question. They said that how much did he have at the end, the one who won. So we shall come and say at the end, the amount he has corresponds to 75x. And the good thing, we know the value of x, meaning I can now come and get the amount at the end of the betting. Substitute for x and use a calculator to come up with this. And basically, this is what they wanted. Then question 2 came from National Math Contest of 2018, paper 2, question 3. And it says, the ratio of Grace's weight to Henry's weight is 2:3. If the ratio of Henry's weight to Sam's weight is 4:5, what is the ratio of Grace's to Sam's weight? So you come and say that we are given that the ratio of G to H is 2:3, and this is here. Then the ratio of H to S is 4:5, which is that. Now our interest, do you see this? H, and these are the corresponding ratios. So we are going to look for what to multiply it to both so that we get the similar value or at this point and at this point. So the best is to multiply. First of all, the LCM is what to look for. LCM of 3 and 4 is 12. So how can you get 12? For this one, it means 12 divided by 3 is 4, so I'm going to multiply throughout by 4. That's why you're saying 2 times 4 and 3 times 4 to give you 8 to 12. Then this one, 12 divided by 4 is 3, so I'm going to multiply throughout by 3 and be able to get a similar value here. When I get the similar value there, they said the ratio of G to S, and it is here. So in that case, it means that I can easily get that ratio by saying 8 to 5. It is even here GS, which will be 8 to 5, and basically that's what they wanted. Then question 3 came from National Math Contest for 2018, paper 1, question 10, and it says, the ratio of boys to girls in a class is 7 to 5. If there are 6 more boys than girls, how many girls are in the class? So let X be the number of girls in the class. They told us ratio of B to G is 7 to 5. But they told us there are 6 more boys in the class. So if there are X girls, there should be X plus 6 boys. So you come and say, here it is X plus 6 boys, X girls. The ratio is that. Now ratio is the same as division, so this becomes X plus 6 over X, then it becomes 7 over 5. Then you cross multiply to come up with that. Then next is expand. I think you cover these rules under the video of solving linear equations. Then my aim is to make x the subject. So what I'm going to do, I'll bring this one this side to get 2x. Then divide both sides by 2 to get 15. And that means there are 15 girls in the class. Question 4 came from National Math Contest of 2015, Paper 2, Question 8, and it says, two numbers are such that their difference, their sum, and their product are in the ratio 1 to 7 to 24, respectively. Find the product of these two numbers. So the first thing to do is to let the numbers be x and y. Therefore, they told us the difference, that is x minus y, the sum, that is x plus y, and the product, that is xy, is in the ratio 1 to 7 to 24. So you are going to pick pairs of ratios. So if I pick these first two, they will correspond to the first two here. Meaning that this over this is the same as this over this. Then I cross multiply to give that. Then collect like terms. What I've done, take this side to come up with 8y and this side to come up with 6x. When I make x the subject, I'll take this on this side to become 8 over 6, which is 4 over 3 when reduced. Now I've got one equation. What about another pair? If I choose this and this, the ratio I'll use this with this, as you can see here. So still fraction, then cross multiply and get equation 2. Now the good thing, I know x in terms of y, and we covered this under the video of simultaneous equations. So now I'm going to use the method of substitution. So where there is x, I'll put there 4y over 3. Where there is x, I'll put there 4y over 3. So let's do that. Then, so I'll put where there is x, where there is x. Okay, here I've not yet substituted it. So but now I've substituted it. So this times this over 3 gives this. And here it is now this times y. So let's reduce that. When I reduce, you realize that 32y minus 24y gives you 8y. Then this one gives you 4y squared over 3. The good thing now, I have only one unknown, meaning I can get its value. So cross multiply to get that. We'll put everything on one side and factorize. The good thing, we covered a lesson of factorizing algebraic expressions. So here the highest common factor is 4y. So put 4y outside. It means that here remain with 6, here remain with y. And we also cover this under quadratic equations, whereby either this is 0 or this is 0. Meaning I have two values of y, this is equal to 0 or y equal to 6. But y cannot be 0, therefore y is 6. And after getting y, I will go back and remember that there is something connecting y and x. So I'll come and substitute for y in equation 1 to get the value of x. And the value of x is 8. Therefore, those are the numbers they wanted. Question 5 came from the National Math Contest of 2014, Paper 1, Question 5. And it says, the ratio of the ratio of children to adults at a party is 2 to 3. A busload of 30 more children arrives at the party. And now the ratio of children to adults is 3:2. How many people were at the party before the bus arrived? So the first thing to do is to let x be the number of people at the party before the bus arrived. That means that number of children before the bus arrived was 2 over 5x, because 2 is here, over 5, which is the total ratio, times the total number of people. Okay. Then what about after the bus arrived? After the bus arrived, the ratio changed. Now the ratio of children is now 3 over the total, which is 5, times the total number of people. Remember, initially there were x people, but now they added 30 more children, so it becomes 30 plus x. So this is what we know, that the total number of children before plus 30, because the bus only had children, will be equal to the number of children after. So come and substitute. So now we have got a linear equation with fractions which we can solve. So get LCM to come up with that. Then this can cancel to remain with this. Then you collect like terms. Take this down to this side and this 2x this side. You'll come up with x as 60. Therefore, initially there were 60 people at the party. So that's what they wanted, and thanks for watching, and be reminded the next video will be on solution for assignment 4. So if you're not a subscribe, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.